should be more than 13%. Alternative energetics, and more precisely, the production of energy from RES, is still in the stage of development. For almost 10 years of the implementation in Ukraine, Ukraine has significant potential of the main types of RES, but at this present time, they constitute a rather small share in the overall energy balance in the state. The total primary energy supply from 2012 to 2050 under different scenarios for the development of alternative energetic in present of figure 2. We have three scenarios. First scenario is conservative scenario. This scenario is we have the freezing of technologies at the current level when the characteristic of most energy technologies remain unchanged by 2050 compared to 2012. For example, only a very small part of the rest potential is used. Second scenario is liberal scenario. This scenario we have development of the energy sector under free and perfect competition in the national energy markets. And second is a revolutionary scenario. This is rapid development of RES under the targeted renewable energy development policy. The structure of the predicted final energy consumption by 2050, according to liberal and revolutionary scenario, are presented of figure 3 and figure. You can see this is liberal scenario, and you can see next is this is revolutionary scenario. Due to the size and diversity of natural landscape, Ukraine has a significant natural potential for energy production. From most RES, high levels of the solar radiations, powerful wind power on the coast and in the mountains, river with powerful hydrological energy reserves, and large resources and large agricultural areas for biomass production. Potential solar energy production in Ukraine is about 350 billion kilowatt per year. Here with non-state and state institutions, even higher education institutions are engaged in the production of solar power. So Khmelnytsky National University installed a 150 kilowatt solar power station in 2017 as a scientific-led initiative. In the 2080s, power of solar power station was expanded to 650 kilowatts, figure 5. You can see our university, you can see a rooftop solar power station of Khmelnytsky National University. The cost of the Khmelnytsky National University solar power station is about 13 million Ukraine hryvnias, around 400,000 euros. An important fact that significantly affects the performance of solar power plants is the orientation and angle of the solar panel. Today, the main direction of improving the efficiency of electricity generation by solar power plants is the creation and use of two-coordinate solar tracking system, which provides the increase of the energy efficiency by at least 30 to 50% compared to stationary power plants without a system to optimize the position of solar panels. For ensuring the maximum performance, solar panels should be placed perpendicular to the flow of solar radiation. The angle of incidence of sun flights depend on the time of day and season. Therefore, the actual task is the correct positioning of the solar panels and ensuring their maximum efficiency. Trackers can be implemented on the basis of different principles. First principle is a control of motors by means of several photodetectors. Such device has two or more photoresistors, which the moment of the sun, the illumination of the resistor becomes different. The device analyzes the illuminance and transmits control signal to the motors until the light flux on the photocells is the same, and the motor rotates the solar panel. Second one is control of the movement of the tracker at azimuthal and zenith angles. For the correct positioning of solar panels, need to compensate for true movement of the Earth. daily movement associated with the rotation of the Earth around its axis, and the annual movement associated with the Earth's rotation around the Sun. The aim of our research is development of the system that would track the Sun regardless the clouds. The main factor of the aiming at the Sun in high clouds is the calculation of its position. For calculation the position of the Sun, we can use an online calculator that determines the zenith and azimuth in degrees. The input data for intelligent solar tracking system are the coordinates of the location of the solar tracking system and time. The presence of this data allows calculation with significant accuracy and the coordinates of the position of the Sun, which will be transmitted to the system. And next figures show intelligent solar tracking system in Khmelnytskyi National University. This is our solar laboratory, solar power laboratory. The following equipment was selected for implementation in intelligent solar tracking system. First of all, it's Arduino Uno board with Wi-Fi module based on ESP8266 microcontroller, MPU 6050 sensor, and finally driver TB6612F and G for control of two directions of the motor. You can see this wiring diagram of the interior measuring sensor MPU 6050 to Arduino microcontroller. The wiring diagram of TB6612F and G driver to Arduino controller is shown in figure 8. The diagram independently controls the two motors you can see on the right corner and right down corner of the intelligent solar tracking system. That allows directing the solar panel to the Sun. Outputs A01 and A02 are for controlling the motor that rotates in azimuth, and B01 and B02 are for controlling the motors for rotates at the zenith. Arduino controllers receive data from MPU 6050, process it, and control the motors via the TB6612F and G drivers, which rotates the solar panel. The intelligence of the solar tracking system is that the system first determines its coordinates using GPS and then calculates the coordinates of the zenith and azimuth of the Sun and positions the surface of the solar panel at the angle of 90 degrees of the Sun. The intelligent solar tracking system is mobile. It positions the surface of the solar panel at angle as 90 degrees to the Sun while changing its coordinate in space. The system also has sensor for wind detection and speed. If wind speed exceeds the maximum allowable value, the system changes the position of the panel parallel to the wind direction. This is important for reliability of such system and to protect them for destruction and high wind speeds. The system also has strain gauge that record shocks on the surface on the panel in case of hail, which can damage the solar panel. If the hail sensor is activated, the system positions the solar panel vertically, which protects the panel from hail damage. The appearance of Arduino Uno and Wi-Fi R3 boards from Robotodin is shown on the next picture. You can see appearance of Arduino plus Wi-Fi module. This is ESP H262 board. Using the Wi-Fi module, we can control the intelligent solar tracking system through a site that can create it in the memory of the ESP chip. You can see ESP chip on the board. So in this case, we can obtain value from our solar panel from the site, and we can position our solar panel perpendicular to the Sun. So at the final of my presentation, let me show conclusions. First of all, this is a mechanical design for position the solar battery in space, a flight sensitive photodetector for tracking the position of the Sun in two coordinates, a diagram of the intelligent solar tracking system were developed. The developed intelligent solar tracking system minimize energy consumption for control and increase energy efficiency of electricity production. The use of such system provides a significantly increase the amount of electricity produced by solar panels. This is currently the lowest level of intelligence that can be further developed by means of neural networks and ontological agents to control a large number of panels in automatic mode. The author planned to test alternative approaches to developing an intelligent solar tracking system, for example, using ontology-based intelligent agents and using artificial neural networks. Thank you for your attention.
Thank you. Questions, please, dear colleagues?
I have one question, if you allow me. Could you tell us the practical use of such a system, because it looks great, and what is the purpose of this system for the university?
Thank you for your questions. The purpose of this development is that our university has a stationary solar power station. If we can implement our tracking system, solar tracking system, to our solar station university, we can increase electricity production. It's about 40%. This is very important. In this case, we need a small area of the land, but you can see we have a top roof university station, and we did not put our solar panel on the land. We just only put on the roof of our university.
Thank you for your reply.
Thank you. More questions, please?
How much profit did you make?
About 40%.
Thank you.
You're welcome.
More questions, please? No more questions. Thank you, dear Valery. Our next presentation is Intelligent Information Technology for Supporting the Medical Decision-Making Considering the Legal Basis. The speaker is Elizaveta Hnachuk. Welcome, Elizaveta.
Sorry. Dear colleagues, let me present our research, Intelligent Information Technology for Supporting the Medical Decision-Making Considering the Legal Basis. The content of our presentation is represented on the second slide. The introduction of the latest information technologies in all areas of human activity, the purpose of automating the routine work, reducing the manual labor, and minimizing the human factor is a strategic goal of the information society in Ukraine. Medical information technology must meet four requirements: efficiency, safety, novelty, and economic benefits. Today, decision-making process in the field of medical services are cumbersome, complicated, and non-transparent. The productivity of health workers is significantly increased due to the successful implementation and use of decision support systems and information technology. Successful implementation of medical software, information technology, and decision support system provide doctors with new information on the specialty, increase the efficiency of doctors, increase the productivity of medical resource, and strengthen the integration of Ukrainian medicine into the medical space of Europe. Intelligent or intellectualized systems and technologies facilitate medical decision-making and are promising tools in the era of evidence-based medicine. The most important and complicated in the task of developing the multidisciplinary medical information technology and decision support system, because in requirements for such information technology and decision support systems, the software development standards and standards in medicine and law need to be considered, preventing to losses of information owing to different understandings of information needs and contexts. Service contracts are the most common type of contract of civil law. The contract for the medical services provision, therapy, transplantation and donation, the reproductive technologies use, dental services is the most common legal basis for the medical services provision. A contract for the medical services provision is an agreement whereby a doctor or clinic at the patient's request must relevantly serve the patient, and the patient must pay a certain amount of money specified in the contract for the services provided to him. Implemented and used medical information technology and decision support system substantially increase the correctness of the contract from the point of view civil and medical law. Therefore, the conclusion of a contract for the provision of medical services, in particular, the verification of the existence of all significant conditions in the contract, is becoming increasingly important with the purpose of ensuring the safety both the doctor providing the service and the patient receives the service, as the lack of significant conditions in the contract leads to serious problems and legal conflicts. The date, there is no single form of contract for the provision of various medical services in Ukraine. The legislative acts have no norms which give the definition and regulate the procedure for concluding the medical services contracts. Resulting many medical services contracts have aggravating conditions for the patient, offer illegal methods of dispute resolution, and have no characteristic for individualizing the medical services. These disadvantages often lead to adverse legal consequences for both the patient and the clinics, which continue to use contract models that have obvious legal limitations. Of course, every clinic cannot have a law for preparing the medical services contracts. Multidisciplinary medical decision support system and information technology for the medical law domain allow free and automated verification of all essential conditions existence in the contract and the provision of advice of the conclusion of the contract or not. State-of-the-art unknown decision for supporting of the making the medical decision based on legal grounds was conducted. We are interested in whether the known methods and tools support decision making on the using reproductive technologies possibility is criterion first. Criterion second, the donation and transplantation possibility. Criterion third, the possibility of concluding therapeutic services contracts. Criterion fourth, the possibility of dental services contracts. Criterion fifth, the possibility of general medical services contract. In addition, we are interested in whether known tools automate parsing the contracts and drawing conclusions about the possibility or impossibility of concluding a contract. Criterion 6, whether these tools provide a request, what exactly is missing in the contract for its conclusion, if a conclusion about the impossibility of concluding the contract is drawing. Criterion 7. 31 systems were considered to see if they met the proposed criteria. As a result, we see on the 6th slide that none of the known system satisfies all 7 criteria. So the development and using the intelligent information technology set of processes, methods, and tools for accumulation, processing, and transmission of the primary information with the purpose of obtaining information product with new quality for supporting the medical decision-making, considering the legal basis in an urgent problem for Ukraine. The conducted state-of-the-art of known decision for support of the making the medical decisions based on legal grounds showed none of the known solutions satisfies all 7 criteria in the complex. Therefore, developing and implementing intelligent information technology for supporting the medical decision-making, considering the legal basis, which would meet all the above 7 criteria simultaneously, is the purpose of this study. On the basis of the modeling the information flows in the medical decision-making process, considering the legal basis and the investigation of information flows in the process of evaluation information, which is available for medical decision-making, considering the legal basis conducted by the authors in previous work, and theoretical principles of information technology in the form of the method for decision support, the block diagram of intelligent information technology for supporting the medical decision-making, considering the legal basis, a set of process methods and tools for accumulation, processing, and transmission of the primary information with the purpose of obtaining information product with new quality is developed and present on 8th slide. Intelligent information technology for supporting the medical decision-making, considering the legal basis, gives the support for decision-making on the possibility of using reproductive technologies, the possibility of donation and transplantation, the possibility of concluding therapeutic services contracts, dental services contracts, and general medical services contracts. In addition, intelligent information technology for supporting the medical decision-making, considering the legal basis of terms, the semantic parsing of contracts and drawing conclusion about the possibility or impossibility of concluding a contract, as well as provides the request indications, the reasons for impossibility of concluding a contract. For example, indications the missing significant condition in the contract. If it was concluded that it's impossibility to conclude such a contract. Figure 1 showed that the proposed intelligent information technology for supporting the medical decision-making, considering the legal basis, consists of first, parsing the appropriative medical services contract, for example, using an intelligent agent for parsing natural language documents, which was developed in previous work. Methods of decision-making is a field of legal regulation of surrogacy, method of decision-making on civil law regulation of contract for the provision of in vitro fertilization, method for supporting the decision on the possibility of donation and transplantation on the basis of civil law, a method of decision-making process on civil law regulation of contracts for the provision of therapeutic services, method for legal regulation of the dental services contract, and method of decision-making about conclusion of contractual obligation in the field of medical services. The main purpose of the developed intelligent information technology for supporting the medical decision-making, considering the legal basis in the automation, minimization of the human factor impact, and simplification of the implementation of the contracts, parsing and drawing the conclusions about the possibility or impossibility of concluding the contracts of reproductive technology, of donation and transplantation, therapeutic services contract, dental services contract, and general medical services contract. Let's consider for a function of the development intelligent information technology for supporting the medical decision-making, considering the legal basis. For example, the input of the development information technology is the medical services contract. It was determined that this a contract for the provision of in vitro fertilization. Developed intelligent information technology for supporting the medical decision-making, considering the legal basis, conducted a semantic analysis of the provide contract for the provision of in vitro fertilization, as well as processing the contract using the method of decision-making on civil law regulation of the contract for the provision of in vitro fertilization, which was developed by the authors in previous work. Resulting in the analysis of the contract, a set of significant conditions which are absent in the analyzed contract was formed. The set of missing significant condition has the form equal indication for in vitro fertilization, woman's age, woman's legal capacity. It is not empty, so intelligent information technology for supporting the medical decision-making considering the legal basis form conclusion of the impossibility of concluding the appropriate medical services contract and a request for addition of the in vitro fertilization contract. Thus, the developed information technology helped to avoid concluding the incorrectly execute contract which have no significant conditions and could lead to negative effects for one or both parties. The conclusion of the medical services contract in particular verification of the availability of all significant conditions in the contract is becoming increasingly important with the purpose of ensuring the safety of both the doctor providing the service and the patient receives the service, as the lack of significant conditions in the contract leads to serious problems and legal conflicts. Many contracts for the provision of medical services of various kinds contain aggravating condition for the patient of a non-legal method of dispute resolution and do not contain characteristics that individualized medical services. These shortcomings can lead to unfavorable legal consequences for both the patient and the medical organization, which continue to use such models of contracts which have obvious restrictions on the legal side. Of course, not every clinic can afford to hire a lawyer to prepare contracts for the provision and medical service. The developed intelligent information technology for supporting medical decision-making considers the legal basis, gives the opportunity to verify the correctness of the structure and content of the appropriate medical services contract. Such verification allows unmistakable from the point of view of legal basis decisions on the possibility or impossibility of concluding the contract, minimizing the subjectivism influence and the human factor, and elimination the need to pay for legal services by the clinic. The proposed intelligent information technology for support the medical decision making considering the legal grounds provides support for decision making on the possibility of using reproductive technology, on the possibility of donation and transplantation, the possibility of concluding contracts for therapeutic services, contracts for dental services, and general contracts for medical services. In addition, intelligent information technology for supporting the medical decision making considering the legal basis optimizes the semantic parsing of contracts and drawing conclusions about the possibility or impossibility of concluding a contract, as well as provides a request indication the reason for impossibility of concluding a contract, if it was concluded that it is impossible to conclude such a contract. Thanks for attention.
Thank you, Elizaveta. Dear colleagues, question, please. Pavlo, please.
Yeah, thank you very much for your presentation. Could you please go back to the conclusion, the slide a bit, and let it be here. Thank you. So you mentioned that your information technology provides some sort of verification. As I know correctly, verification means some calculations and mathematical results. So have you applied any mathematical models or probably some specific criteria which provide computational results based on which healthcare professionals can make good decisions? Are there any math? And if not, are you going to apply something? Thanks.
Thanks for questions. I need help for translate.
I can translate if it's possible in Ukrainian or in Russian, if the committee allows to do that. Yeah. Чи ви використовували яку-небудь математичну модель або просто якусь математику, якісь математичні критерії, на основі яких інформаційна технологія може давати рішення, щоб верифіковувати те чи інше рішення, чи воно є правильне, чи неправильне?
We used the ontologist approach, порівнювали real and ideal ontology, and on basis порівняння ontologies, comparison ontologies, our intelligent information technology decision on the possibility of concluding the contract.
All right, got it. Thank you.
Thank you. More questions, please?
Yeah, I've got one question.
Okay, welcome.
So in your technology, you apply different methods for different purposes. You show the slide, the great slide with a lot of methods. So could you name decision-making methods in your technology except for ontology and except for ontology approach? Yeah, I mean this slide, yeah.
Please translate.
Yeah, I may translate. У вашій технології, так, ви використовуєте багато різних методів для різних цілей. Так? Назвіть, які саме методи ви використовуєте для прийняття рішень, окрім онтології. Так? Ви назвали онтологію, підхід онтології. Що ще? Які методи?
Це як на цьому етапі. Production rules and ontologies are problem English.
I see. So the main is ontology and productive rules.
Production rule, решта in future works.
Yeah, I see. Okay, thank you.
Thank you. More questions, please?
What multi-agent package did you use?
Наразі,
Ну, наприклад, Jade, там, чи інші мультиагентні пакети.
multi-agentні packets no used. This work наразі theoretical phases and in future we used найбільш підходящий до нашого дослідження інструмент будемо використовувати.
Я вам пропоную Jade, он під Java. Так що я от їм теж використовуюсь. І там є якраз антологія контракт.net. Якраз там для вот этих контрактів.
Thank you for proposal.
Thank you.
Thank you. No more questions? Okay. Next presentation is method for determining the informativeness of the software requirement specifications. Speaker is Ivan Lopato. Ivan, welcome.
Hello, everyone. My screen is visible?
Yes.
Okay. So, today I want to talk about a study which I investigated with my colleagues. My name is Ivan Lopato and my colleagues are Mikita Vebiga, Yuri Forkun, and Artem Boyarchuk. The topic is method for determining the informativeness of the software requirement specifications. So by statistics, most of the bugs in software are introduced at the stage of requirements formation or as the result of poorly quality software requirement specification. In Figure 1, we can see the distribution of software bugs by development phase, where only 7% of the bugs reside in the code phase, whereas most of the bugs are reside in the requirement phase. Figure 2 represents the correlation between high quality requirements and low time and budget expenses, and between low quality requirements and high time and budget expenses. In Figure 3, we can see how much of the requirements defined by common natural language and how small a percentage of the formalized language of requirements. Today, the key to assessing the quality of the software is the approach based on the square model. Software quality assessment according to this model is based on the evaluation of sub-characteristic and quality characteristic by attributes specified in ISO 25023 standard. Important criteria for specifying software requirements are completeness of the requirement specification, sufficiency of information in the requirements, and informativeness of the requirement specification. Table 1 on the current slide represents a summary of the conducted analysis of known tools for software requirement specification analysis, which shows that none of the known tools provide the possibility of determining the informativeness of the requirement specification. Therefore, it is necessary to develop and implement the criteria and method for determining the informativeness of the software requirement specifications, which is the purpose of this study. So, to assess the informativeness of the specification of software requirements, it is necessary to assess the informativeness of the quality measures of the specification in terms of their impact on the characteristic of the software quality. Criteria of informativeness of quality measures of the software requirement specifications consist of relevance, veracity, significance, objectivity, and compliance. Each criterion is ranked ranked in range from 0 to 1 by calculated step, from least influential to most influential, from least significant to most significant, etc. For example, relevance is consists of RSP and ABCI, where RSP is in range from 0 to 1, the rank of influence of the quality measure on certain characteristic, where 0 corresponds to the smallest influence, 1 corresponds to the greatest influence, and ABCI is in range from 0 to 1, the rank of ability of the quality measure to clarify the value of the software quality characteristic, where 0 means that the measure least clarifies the value of the characteristic, 1 means the greatest degree of clarification. Considering the defined criteria of informativeness of the measures of the specification of requirements, the method of determining of informativeness of the specification of software requirements consists of the following stages. First, it is division of the interval into subinterval for each software quality characteristic. Next, it is evaluation of all measures of each quality characteristic according to each of the criteria of informativeness. Next, it is sorting of quality measures and assignment to each measure the corresponding rank. Next, it is formation of a matrix of informativeness of measure for each characteristic. And finally, it is calculation of the indicator of informativeness. The interval from 0 to 1 is divided into subintervals depending on how many quality measures of the specification affect the quality characteristic. So the quantity of subintervals equal quantity of different measures minus 1. For an ideal specification in which there are absolutely all the measures on which the quality characteristic depend, the number of subintervals, the step, and the division of the interval into subintervals for each software quality characteristic are presented in table 2 that currently on the slide. Then we assess with the help of the experts the importance of each measure of quality characteristic according to a certain criterion, then perform sorting of measures, and for each measure is assigned a corresponding rank. The result of such assessment is the method of informativeness of measures for each characteristic, whereas the first one contains estimates for the measure number 1 of characteristic, the second one contains estimates for the measure number 2, etc. The last one contains estimates for the measure number n of characteristic. Number of measures are different for each characteristic, and the maximum number of measures are presented in table 2 for each characteristic. So in this table, we can see the quality characteristic and quantity of different measures. Next, the next step, we assess the informativeness of the specification for the definition of each of the characteristics. To do this, we calculate for each metric the number of elements belonging to a certain range. And after this, to find the informativeness of the specification for determining each of the characteristics as the ratio of the obtained number of elements to the total size of each matrix. The obtained indicator will reflect the informativeness of the specification for determining the characteristic of the software quality. Thus, the criteria and method for determining the informativeness of the specification of the software requirements are proposed, which determine the informativeness of the specification on basis of the characteristic of the software quality. For example, let's consider the measure on which functional suitability depends. List of the measures you can see on the slide. The number of measures on which the functional suitability characteristic depends is 9. So the number of subintervals is 8 with the step of 0.125. Next, we divide the interval from 0 to 1 with the calculated step and evaluate with the help of expert each measure of the characteristic according to a certain criteria. Then perform sorting of the measures and assign each of the measure appropriate rank. After expert assessment, we obtain such a metric. For example, the most influential, according to expert, is the measure number of functions. Next in influence is the measure operation time, then the measure functional implementation completeness, and so on. And the least influential is the number of inaccurate computations encountered by users. Similarly, the expert assessing the other quality measures by criteria. Next, let's calculate for the obtained matrix the number of elements that belong to a certain range. For example, let's calculate the number of elements that belong to the range from 0.5 to 1, just because experts recommend such an interval for functional suitability. Under such conditions, 35 elements are in such range for the obtained matrix. Then the informativeness of the specification for determining the functional suitability characteristic is 55.56%. So today, number of software projects is growing rapidly, and a significant amount of them is big and complex systems, which with a lot of requirements, which should be quite informative for avoiding extra cost and reduce the number of bugs in the systems. The conducted analysis shows that today we have no tools for determining how much of the software requirement specification is informative. So therefore, it is necessary to design and implement such criteria and method for determining the informativeness of the software requirement specification. Our work proposed the criteria and method for determining the informativeness of the software requirement specification in accordance with the standards for assessing software quality. Thank you for listening.
Thank you, Ivan. Questions, please, dear colleagues?
I have one question, if you allow me. Ivan, what is the general purpose and outcome of your study? I mean, where will your method be used, and some kind of software or decision support system? So in general, what is your study aimed at?
Thank you for the question. This study proposes a method which we can use for calculate the informativeness of our software requirement specification. So when applying this method, we can say how much of the system we know from our requirements. So in the terms of this value that we obtained, 55, almost 56% of the system, their behavior, their quality, we can know from our software requirements specification. So, this method can further be implemented in intelligent agent for assessing the software quality at all.
Thank you.
I got the answer. Thank you.
Pavlo, please.
Oh, yeah, thank you very much for your speech. Did you did you take into account the wishes of stakeholders while gathering all these requirements? Because as I know, for example, from my own experience, what stakeholders want during the implementation of software values the most. And did you consider them, I mean, these wishes? And if so, what measure did you use to cover these wishes, for example?
Now, the wishes of customer is considered in software requirements specification. This method isn't for assessing the customer's wishes. It is assess only software requirements. It is about quality of software, not about what we implement and what customer want.
So it's requirement specifications based on the verification, but not the validation. Because, for example,
yes, it's not about validation. It's rather the verification, not validation.
Understood. Thank you.
Thank you. Thank you, Ivan. Yevhen, please.
Small
Last
remark.
question, please.
Criteria should be replaced by indicators or features or characteristics. Ну, в критерії это min, max, ну, це характеристик, не критерія.
Okay, I will think about it.
Thank you, Ivan.
Thank you for listening.
Next presentation is method of forecasting the characteristics and evaluating the implementation success of IT projects based on requirements analysis. The speaker is Olga Pavlova. Welcome, Olga.
Thank you.
I strongly ask all participants to follow the rules from 7 till 10 minutes to speak and from 3 till 5 minutes to answer questions. Welcome, Olga.
Thank you. Hello, dear participants of the conference. My name is Olga Pavlova. I'm a PhD student of Khmelnytsky National University. And let me introduce our common work with my colleagues, the method of forecasting the characteristics and evaluating the implementation success of IT project based on requirements analysis. According to the statistics, all IT projects are divided into successful, challenged, and failed. Successful projects are those which were completed within time and budget. Projects which were overdue, overspent, or did not have the necessary capabilities and functions are considered challenged. Projects which have been cancelled before completion or have been delivered but are never used are considered failed. As we can see from this slide, currently is average 50% of all projects are considered challenged. As this slide shows, the share of challenged projects is about half of all projects. The share of failed projects is about 1/5 of all projects, and only 1/3 of all projects are successful, which can be relied on and worth spending money. Among the possible failures of IT projects are unclear and incomplete requirements, insufficient participation of users in the project, absence or insufficiency of necessary resources, poor planning, frequent changes of requirements, novelty of the used technology for the organization, absence or insufficiency of appropriate project management, absent or insufficient support by senior management of the project and project team, incorrect understanding of purposes or not enough analysis of project requirements. A majority of errors are made at the initial stages of the project lifecycle. IT project requirements which contain insufficient, inaccurate, incomplete, and contradictory information cannot be successfully implemented. The analysis of a large number of projects showed that the gathering inaccurate requirements is one of the primary software failure causes. The analysis of methods and tools of determining the characteristics of projects showed that they focus on ready projects rather than on existing requirements, i.e. are unsuitable for the early stages of the life cycle of IT project. The investigation of requirements analysis methods and tools showed that they are aimed at monitoring the requirements implementation rather than determining and forecasting the values of the IT project characteristics. Therefore, the existing requirements analysis methods and tools are not acceptable for quantifying the characteristics, for characteristic forecasting, and for assessing the IT project success. Thus, the actual task is the analysis of the requirements for IT project in order to forecast the characteristics and evaluate the implementation success of IT project. In the earlier works, the success of IT project at the design stage is evaluated on the basis of the predicted values of the main software project characteristics, such as project duration, cost, complexity, and quality. The method of forecasting the characteristics and evaluating the implementation success of IT project based on the requirements analysis consists of the following stages. The first is neural network-based forecasting of IT project characteristics based on analysis of the requirements. The second one is interpretation of the obtained value of project characteristics based on the success rate of the IT project. The third one is assessing the degree of IT project's implementation success based on the project success rate. And the last one is forecasting the IT project success category, successful, challenged, or failed, on the basis of degree of the project implementation success. The first stage of the method is neural network forecasting of project characteristics based on the analysis of the requirements. The result of artificial neural network will be a set of values where 0 means not enough data for forecasting the characteristics. 0.08, the value or the characteristics negatively affect the project implementation success. 1, the value of characteristics has a positive effect on the project success. The multi-layer perceptron is the most suitable for solving the problem of requirements analysis of forecasting the characteristics of IT project. If different type of neural network will be used, its nature will be artificially distorted, resulting in inconsistent or results of the artificial network. Based on the obtained values of the artificial neural network, both developer and customer find it difficult to assess the IT project's implementation success in complex. So the second stage is the interpretation of the obtained project characteristics values. For finding the success rate of IT project, let's divide the characteristics, the quadrilateral, into the right triangles and find the area for each triangle by two known sites characteristic values. Then we add the results areas of the triangle by the formulas 1 to 4. According to formula 5, the maximum best or standard value of the success rate of a IT project is calculated by the formula 6. By itself, the IT project success rate is also informative for the developer and for the customer. So the next step is assessing the IT project implementation success degree P on the basis of the project success rate by the formula 7. Based on this analysis, the rules for determining the success category of the IT project are developed. If P is less or equal 0.18, then the IT project is probably failed. If P lies between 0.18 and 0.70, the IT project is probably challenged. And if P is more than 0.70, the IT project is probably successful. For verifying the adequacy of the proposed method, let's assume that artificial neural network processed the requirements for 5 projects and we obtained the following results. Therefore, of the 5 considered projects, only 1 is likely to be successful. 2 projects probably will be challenged, and 2 will be failed. Graphical representation of success rate of 5 considered IT projects and of the standard or maximum or best value is presented on this slide. As we all know, all iterations during the IT project are divided into groups planned and unplanned. The proposed method enables minimization of the unplanned iterations numbers and thus reduces time spent on rework at later stages of the process life cycle. And significantly reduces their work after completion of initial work, thanks to early detection of defects of requirements. In the given figure, the black line shows the time and human resources spent on initial work. A solid red line shows time and human resources for rework. The dotted red line shows time and human resources required for rework, which become possible due to use of the proposed method. Therefore, during the research, the method of forecasting the characteristics and evaluating the implementation success of IT projects based on requirements analysis was further developed. The proposed method consists of neural network-based forecasting the project characteristics based on requirements analysis, interpretation of the obtained values of project characteristics based on the success rate of IT project, assessing the degree of IT project implementation success on the basis of the project success rate, and forecasting the success category of IT project, successful, challenged, or failed. The proposed method allows to minimize the number of unplanned iterations and thus to reduce rework time at the later stages of the project life cycle, as well as significantly reduce rework after completion of initial work due to early detection of defects of requirements and early elimination of the revealed defects. The directions of our further work are development and realization of artificial neural network that will forecast the IT project characteristics based on the requirements analysis, design and development of an ontology-based intelligent agent for semantic analysis or parsing of project requirements. Therefore, the user will be able to check the updated requirements each time without spending a lot of time and effort on this. and it all leads to developing of an intelligent agent-oriented system for forecasting the characteristics and evaluating the implementation success of IT projects based on requirements analysis. Thank you for attention.
Thank you, Olga. Questions, please? Evgen, please, welcome.
Some question. How did you choose the number of hidden layers and neurons in them?
Thank you for your question, but I need to say that this work is only on the first stage. We didn't make the experiment yet, so we didn't use the neural network itself. So after this work will come the next stage where we will be using the real artificial neural network, and I think the results of the experiment will be shown on our next works, so it will be in the future. Thank you.
Second question, why did you choose the multi-layer perceptron for forecasting?
Thank you also for the question. Why multi-layer perceptron? Because we decided that it is the most suitable type of neural network for solving this problem, the problem of requirements analysis and forecasting the characteristics of IT project. So if different type of neural network will be used, its nature will possibly be artificially distorted, resulting in inconsistent result of artificial neural network. So I think in my opinion, the perceptron is the most suitable type for this work.
Thank you.
Thank you. More questions, please? Pablo, please, welcome.
Yeah, Olga, thank you very much for your incredible speech. I would like to ask a question. Did you do any field experiments? I mean, did you gather some data by polls, interviews, maybe listenings or something else?
Thank you for your question. We will. The answer is clear. Yeah, we will. But as I already said, this work, this paper, this research is at the first stages of development. So it will be in the future. As you know, our last research is closed. Yeah, you know why? Because of the funding of my doctoral, and this research is the new one, so a new field of work, so it will be conducted in the future, the experiment, the poll, the neural network, but thank you for your hint of how to do the survey to gather the necessary data.
Awesome, I'm eager to read it. Thank you very much for your answers.
Thank you. More questions?
May I ask one more question?
Yes, welcome, Svetlana.
So you named intervals from 0 to 8/10, from 8/10 to 1, for indicated whether their project is successful or not. So are these rate indicators common for such tasks, or is it your own idea to divide these intervals in this way?
This is pre-assumption. So we just assume that this interval will be responsible for the for such type of success rate. If we will conduct the experiments, perhaps we will change these intervals somehow, but in general, it will. I think the rate will lie in the between 0 and 1. But I think these border lines, as you named, yeah, 0.8 and so on, 0.7. Sorry. It can be changed during the experiment, so experimentally. Now it's only theoretically.
Thank you.
Thank you.
Thank you. Thank you, Olga. Our next presentation is Intelligent Decision Support Agent based on fuzzy logic in IntelITSIS adaptive learning systems. Speaker is Alina Gnachuk, yes?
Yes. Good afternoon, everyone. Can we get me opportunity to share my screen?
Olga?
Sorry, I didn't stop sharing my screen. Now,
Okay.
thank you.
Dear colleagues, let me represent our research, Intelligent Decision Support Agent based on the fuzzy logic in IntelITSIS adaptive and learning systems. There is the content of our presentation on the second slide. Theoretical and tactical training of IntelITSIS is one of the leading places in the current process. In this regard, the planning of the training process of IntelITSIS, which allows more systematic selection of tools and methods of training, as well as the determining criteria for monitoring the level of training of IntelITSIS. Today's realities in the context of the COVID-19 pandemic have made adjustments in the planning and conduct of theoretical and tactical training of IntelITSIS. Therefore, the use of information technology in the training of IntelITSIS is relevant today. There is a literature review on the fourth slide. The use of information technology allows for the training of IntelITSIS in compliance with all quarantine requirements. In the system of training IntelITSIS, much attention is paid to the use of information technology, but the vast majority of domestic works are devoted to the review, prospects of application, and opportunities that can provide information technology in the system of training IntelITSIS. Foreign experts pay more attention to the personal assistance of the IntelITSIS, who allows by measuring and calculating certain parameters to provide recommendation for physical training. From the review, it can be concluded that the vast majority of research is aimed at using information technology to monitor the physical fitness of IntelITSIS, their competitive activities, and assistance to coaches. If we talk about the theoretical and tactical training of IntelITSIS, the vast majority of domestic research suggests either the use of multimedia and cloud technologies for such training, or the use of computer training and control programs in physical education and sports. It is proved in the work that student athletes who studied with the use of computer programs mastered the material better and more successfully than those student athletes who practice without their use. As an effective tool for theoretical and tactical training of athletes, the author proposed the use of an adaptive intelligent and learning systems. Any educational platform aims to provide users with the necessary information to increase their active knowledge of a particular subject area. However, the learning process is a variable that depends on previous knowledge, motivation, and individual needs of users. This raises the question of the importance of developing an adaptive system that takes into account the effective process of learning and acquiring knowledge. As an effective tool for theoretical and tactical training of athletes, the author proposed the use of an adaptive, intelligent, and learning system. The development, the development of learning materials and their availability on the internet is insufficient. More importantly, the knowledge materials must be adapted to different characteristics of users, such as their learning style. Existing e-learning systems are designed to prepare students in relevant specialties, as physical education and sports contain in the courses general information about sports, features of techniques and tactics, and provide an opportunity to test students' knowledge in the form of tests. In the system, the theoretical and tactical training of IntelITSIS, such a generalized approach is insufficient. According to the literature review, none of the known e-learning systems is designed for theoretical and tactical training of IntelITSIS in the chosen sport. To increase efficiency in the formation and development of logical, associative, tactical thinking, improving tactical and theoretical training capacities based on the formation and special knowledge about tactics, types of technical and tactical action, competition rules, history of various sports, it is necessary to take into account the level of training of athletes, his abilities and capabilities. This work is devoted to solving this urgent problem. In this paper, the author proposed the concept of user profile model, which combines both individual user parameters and user action in the system. User profile model is represented by a set 1. The user profile model consists of two sets. set containing the asset's personal information, and set that characterizes the activities of user in the system. The asset's personal information is represented with a second set. The set characterizes the activities of user in the system is represented by a third formula, and the set containing the asset's personal information is described by formula 4. Also, a set representing the methods of perception of educational material is described by formula 5, and the set representing the learning style is described by formula 6. The information contained in the user profile model is not only quantitative, but also qualitative. The best solution for its processing will be the use of fuzzy logic. Mondanis method was chosen as a fuzzy conclusion. According to the Mondanis method, for decision-making, quantitative variables are translated into linguistic terms by phasing, and then operation with them are carried out as with qualitative indicators. After that, a knowledge base is built which contains fuzzy production rules of the form 7. An important aspect in providing adapted content is to build a profile of educational material. The profile of the training material is assigned a weight according to the level of theoretical and tactical material contained in the profile. The values of the weights are distributed as follows. P equals 1 means low level, P equals 2 means medium level, and P equals 3 means high level. Processing of qualitative and quantitative information can be carried out using a fuzzy logic device, intelligent engines, or neural networks. A combination of these technologies is also often used to increase the efficiency of important processing. The use of an intelligent engine in complex systems allows you to particularly eliminate human participation in the processing of information, avoid the loss of important information, minimize errors in the processing of large amounts of information. Those intelligent engines are good at solving a variety of problems, especially when combining different technologies. Given that adaptive learning systems need to process different volumes and types of information, both quantitative and qualitative. In this paper, the author proposed the use of an intelligent engine for the decision-making process in adaptive learning systems for IntelITSIS. The decision-making process of an intelligent engine is based on the analysis of a fuzzy logical conclusion. The result of the agent work will be a decision to provide the asset with adapted training content. The structure of the intelligent decision support agent based on the fuzzy logic in IntelITSIS adaptive learning systems is represented on figure 1. Structure of the intelligent decision support agent based on fuzzy logic in IntelITSIS adaptive learning systems. The intelligent agent models the decision-making process based on fuzzy production rules. The intelligent agent takes into account the previous experience of the player, analyzing the model of his profile and the profile of the training material. The method of decision support by an intelligent engine to provide adaptive content to the asset consists of the following steps. First one, the user profile is analyzed in a set of production rules to support decision-making on the possibility of providing adaptive content. The consequence of each rule is checked, according to which the counter is counted D. The profile of training material is analyzed, which contains material on theoretical and tactical training of athletes, which are divided into appropriate levels. If the value of the counter is D less than 10, then adapted content is provided, where the weight of the profile of the training material P equals 1, that is low level. If the value of the counter 10 less or equal than D, which is less than 15, then the adapted content is provided, where the weight of the profile of the training material P equals 2, that is middle level. If the value of the counter is D greater or equal than 15, then adapted content is provided, where the weight of the training material profile is P equals 3, that is high level. As an example, consider how an intellectual agent forms a conclusion about providing an asset with adapted educational content. Consider the following rules. After analyzing the above rules, the intelligent agent calculates the value of the counter, which is for low level is 4, for middle level is 4, for high level is 5. Thus, after analyzing all the rules of the knowledge base built for a particular asset, the final value of the counter D is obtained, according to which the adapted content is provided. If the value of the counter is d less than 10, then adapted content is provided where the weight of the profile of the training material p equals 1, that is low level. If the value of the counter 10 less or equal than d, which is less than 15, then the adapted content is provided where the weight of the profile of the training material p equals 2, that is the middle level. If the value of counter is d greater or equal than 15, then adapted content is provided where the weight of the training material profile is p equal 3, that is high level. If the knowledge base does not have enough rules for analysis to form the value of the counter, then the training content is provided at a lower level. Currently in Ukraine, there are need to design and develop adaptive e-learning systems for theoretical and tactical training of athletes in the chosen sport. The developer user profile model, which combines both individual user parameters and user actions in the system, allows to take into account all qualitative and quantitative information about the user without looseness. Developed rules and methods of intellectual agent to support decision-making to provide adaptive learning content based on fuzzy logic, provide efficiency in the formation and development of logical, associative, tactical thinking, improving the tactical and theoretical training of athletes. Such rules and methods formalize the decision-making process for the provision of adaptive learning content and the theoretical basis for the development and design adaptive learning systems for theoretical and tactical training of athletes in the chosen sport. Thanks for attention.
Thank you, Alina. Questions, please. Pavlo, please.
Yeah, thank you very much for your presentation. I would like to ask a small question. What software did you use to create a fuzzy model?
We used MATLAB.
Oh, thank you. Good tool set. Good choice.
I have one more question. What is the form of an implementation of such a decision support system or agent? Did you consider it?
It is under development, but a website and mobile application are planned in the future.
Thank you.
Thank you. No, Evgen?
Your agents are reactive or proactive or hybrid?
Could you repeat, please?
Реактивные, проактивные чи гибридные ваши агенты?
I think that it is hybrid because the student do some tasks or tests, and a system can calculate it, their level, but also a coach also can make some notes about the level of the student.
Я вам запропонував би Вулдріджа з Дженкінсом, там вони якраз розглядують вот эти всі різницю між этими реактивними, проактивними, там, гібридними, там дуже добре.
Okay, thank you for your proposal.
Thank you. Thank you, Alina. Our next presentation is towards an efficient knowledge-based recommendation system. The speaker is Huda El-Bouhistri. Huda has connection problems due to hit by a 6 Richter earthquake last Thursday. Since then, they suffer from aftershocks, and so we will watch the prepared video. Do you see my screen? Can you see my screen? Yes. Okay.
Hello, and thank you for being here. I am Huda El-Bouhistri from the University of Petraea in Algeria. Today, I will present my research paper entitled Towards an Efficient Knowledge-Based Recommendation System. Here's the outline of my presentation. I start by an introduction and motivation. Next, I present the related works to my domain. Next, I present in detail our proposal, our methodology. Next, a brief description of the experiment and evaluation, and I finish by conclusion and future works. In a general way, a recommendation system is a software tool and intelligent system that provides the user with suggestions on items or products that meet his needs or are simply likely to interest him. For example, what movie to see, what book to buy, or even what music to listen to. These suggestions are based on the individual's tastes by analyzing the browsing history, opinions, comments, and rates given to products and the behavior of other users. Additionally, food and its impact on well-being, metabolism, and success at school, during sports, or at work have become increasingly important. There are three main approaches: content-based filtering, collaborative filtering, and hybrid filtering. All these approaches share the same approach, which is to convert estimators of users' preference for items into recommendations using explicit and implicit previous ratings as expressions of preference. Food recommendation systems are a relatively recent domain whose state of the art has been studied in different ways. Our review is inspired from the classification proposed by Trent and Trent 2020, which consists of four category classes: food recommendation for health professionals, drive recommendation, physical activity recommendation. Generally, the recommendation systems suffer from the cold start problem because users usually do not provide adequate ratings to nutrition to enable collaborating filtering-based recommendation system, which can lead to an issue called a cold start problem. And most of the profile-based approaches cited in our paper have not suitably dealt with this concept, which makes conflicts in the user profile settings, for example, his preferences with his health conditions. Our work is inspired from all the previous approaches and aims to improve these works and provide a full, fast, and accurate recommendation system. We propose so a recommendation system that means contextual information and visceral information from user preferences and profiles from centralized Internet of Objects devices, and recommends food and nutrition based on users' preferences. The user profile is built from the user's nature and evolves according to the events observed. The architecture of our proposal is sketched in the figure and is composed of various layers to process the information. The proposal is knowledge-based and use machine learning techniques and involves six steps. Our proposal considers both healthy users and users with chronic disease like diabetes and hypertension. Based on the user health profile preferences and contextual information, our proposal provides individualized nutritional recommendation. The first step of our proposal is data collection. This step is achieved by the information gathering layer, which is focused on capturing contextual information, user preference, and all nutrition related relevant information associated to the user. The second step is data processing. In this step, we remove all the duplicate values and the blanks for easier processing. The third step is the data analysis. We consider the data sets individually to gain insights that could help in developing our system. For the user dataset, we create a user profile ontology from an ontology template. For the nutrition dataset, we analyze the gathered data with natural language processing techniques such as tokenization, and we create a MongoDB NoSQL database using associated rules. The fourth step is the profiles dataset clustering. In this step, we apply the clustering algorithm Camins for assembling user profiles according to their common preferences. The purpose of this step is to reduce the profile space. The fifth step is profiles analyzing. As previously mentioned, at the end we get a dataset that encompasses clustered users profiles ontologies. When a user is, we create a profile ontology which will be matched with the clustered ontologies using a semantic distance measure. The most similar ontology is to find the best suitable user for predicting the appropriate recommendations regarding traceability. The purpose of this step is to provide speed recommendations using traceability, that means history. Our system can capture all learning history for further processing. The final step of our recommendation system is the recommendation engine. The recommendation engine is focused on receiving as an input the user profile information and returning it as an output the recommendation food. The recommendation engine mainly goes through three steps. The nutritional context determination is focused on initially filtering out some foods that do not match the user profile and preferences. For example, foods that are not appropriate for a diabetic patient. And second step, express food recommendation based on an optimization approach between user preferences and the nutrition object via Pearson's similarity. Now, for the experiment, to investigate the problem, a set of experiments are conducted and implemented in Python. We will build a user-friendly application with a minimum number of menus. The user only needs to introduce his personal data and click on the recommendation button. For introducing the data gathered from the sensory IoT devices, we connect a device to the PC for this purpose. We perform next a manual recommendation to serve as a comparison point for the recommendation process. We select user's profile, user may be sick or not, and food objects. We conclude that the proposed system needs less time than other algorithms in responding to the query. The response time shows that the proposed system responds faster than other existing systems. So, to evaluate our proposal, we use the precision and recall metrics. Precision is the TP on TP plus FP. TP is the number of relevant iteration recommended, and FP is number of irrelevant iteration recommended. We calculate also the recall with TP and TP plus FN. FN is the number of
Okay. I sent email address of After in chat so that you can contact with After for possible questions. Okay. Next presentation is modeling with fuzzy logic the migration capacity of UV ink components as a factor of potentially harmful pollution of packaging by Vyacheslav Repeta, Valery Zhidetsky, Igor Lyakhin, Olga Cherednichenko. Who is the speaker?
Доброго дня. Справа в тому, що спікером мав бути Ігор Лях, але через непередбачені обставини, через хворобу він не може виступити. Можу коротко виступити я, розказати коротко, але на українській мові про суть нашої наукової роботи.
Of course, the working language of the workshop is exclusively English, but given the problems of the keynote speaker, we will make an exception for one presentation and allow you to report in Ukrainian. Звісно, у нас англомовний воркшоп, але враховуючи хворобу основного спікера, звичайно, ми вам дозволимо, зробимо виключення. Просимо, пане Вячеслав.
Зараз, секундочку. У мене зависли на комп'ютер, я перейшов на другий і ще не зміг перенести презентацію. Я можу просто писати без презентації. Або почекати.
Давайте тоді, можливо, ми зробимо наступну презентацію, а потім повернемось до вас.
Добре, давайте. Давайте.
Okay. Next presentation is neural network forecasting using big data by Sergey Ivanov, Natalia Maksishko, and Mykola Ivanov. Who is the speaker?
I am the speaker, Ivanov Sergey.
Welcome, Sergey.
1 second, please. Okay. Hello. Before I start, I want to thank our organizers and participants. Second international workshop on intelligent informational technologies and systems of informational security. Today, I'm going to present a report on paper 18, a neural network forecasting using big data. That paper was written by Natalia Maksishko, Mykola Ivanov, and me, Sergey Ivanov, the scientist from the Zaporizhzhia National University, Zaporizhzhia, Ukraine. The whole report contains such sections as you see on the screen. As Lauren Florence explained, the success of the use information technologies is determined by the success of digital economy, thus how they are measured and used. However, attention is paid to forecasting in the digital economy, taking into account intelligent systems. Intelligent systems and the use of multidimensional communication determine the emergence of a new concept. According to this concept, it is argued that we are in the era of the fourth industrial revolution, when the virtual world is combined with the physical world using informational technologies. Making forecasts is part of any firm's overall analytics. An important role in the forecasting method is played by the multidimensionality of information and methods of their processing. The use of big data with all of technologies requires new approaches to processing and applying large amounts of data. This is due to the wide range of communication systems used in the innovative companies. The article is devoted to neural network forecasting. The modern economy is characterized by the rapid dynamics of economic process. Under these conditions, forecasting models of neural networks acquire new significance in the process of making decisions. The importance of making management decisions in digital marketing systems is shown in figure 1. Therefore, storage technologies and their processing of information are becoming more and more in demand. The MapReduce model provides for distributed data processing proposed by Google and is shown in Figure 2. In marketing analytical systems, there are many databases where transaction processing is done in real time. Therefore, online data sources system, ODS, provides information for processing in OOTP. OOTP system provides storage and processing of information in real time. The processed data in OOTP is transferred to the data mart systems via the subsequent construction of multidimensional OLAP data cubes. Data sets from set I stored in OLAP and on demand allow you to obtain and conduct analysis with the subsequent storage of data, which are called transactions. To find the predicted value on the prediction interval, a method is proposed that includes the following stages. First stage, analytical analysis of indicators and the formation of a learning matrix from selected values from historical slices of multidimensional databases, OLAP technology. Second stage is NS training. The process of training a neural network is to match to each ML input elements the value of the TVM output matrix corresponding to the mapping in the value of the elements of the weight or matrix. In the process of training the neural network, the task of minimizing the objective function is solved. With this approach, an algorithm is used for training, which is the most efficient not only in terms of errors, but also in time. The neural network in MATLAB is trained using the Levenberg-McQuad algorithm. Therefore, the training of the neural network is represented in time, and the network is tuned in accordance with its error. The magnitude parameter is used to ensure the generation of the neural network and stop learning when the generation stops improving. The test score itself does not affect training and provides an independent assessment of the performance of the neural network during and after training. In the process of forecasting by a neural network, it is necessary to take into account the forecasting horizon. In the MATLAB system, the sim function is implemented, which allows you to supply a variety of input values and get a solution at the output of neural network. The forecast results for the sale of 10 goods are shown in Figure 8. All in all, the paper proposes the use of neural network for predicting multidimensional data, which is built in the MATLAB system. To solve the forecasting problem, it is proposed the construction of the input and target data matrices for training a neural network. The wider use of digital systems makes it possible to apply the proposed approach to forecasting. It should be noted that the use of neural networks in forecasting could have some disadvantages. So, in the process of forming training matrices, if you are no data in the initial information or data presented in distinct form, then an error may appear. And therefore, this drawback in solving the forecasting problem can be eliminated if systems with fuzzy sets are used. Thank you for attention.
Thank you, Sergey. Questions, please. Evgen, welcome.
Why don't you use a recurrent network? Oh, for example, SRN.
Oh, we use this system on, thank you for the question. We use this system on MATLAB because on this algorithm, we can get faster results, and it will be better. Because we look forward for information system on real time that could give forecasts in an hour.
Which is accuracy?
Oh, repeat, please.
Точність яка? Accuracy.
We look, compare some methods, standard methods, and this our model, and our model give better results. Yes, but this compare don't add. We don't add this compare in our paper, but it gives us better results. Yes. Than other standard.
Thank you.
Thank you. More questions, Pavlo? Yes.
Yeah, thank you very much for your presentation. I would like to ask, have you used any other software systems except MATLAB to test your neural network? For example, some Python implementations or C# or some solutions from Microsoft, Amazon, or something else, open source, I mean.
Thank you for the question. We try to use Python, but we don't get a good result, so we use only MATLAB.
Got it, understood. Thank you.
Thank you.
Thank you. No more questions? Okay.
Thank you.
Thank you, Sergey. Vyacheslav, are you ready? Okay. Please, welcome. Вячеслав, будь ласка, якщо ви готові. Включіть мікрофон, будь ласка, бо ми вас не чуємо.
Чути мене?
Так, чуємо, бачимо, розказуємо. Давай.
Значить, тема нашої наукової роботи – це є моделювання нечіткою логікою міграційної здатності компонентів УЕФ-фарб як фактору потенційного забруднення упаковки. З прогресом різних технологій в поліграфії з'явився такий новий тип фарб, як фотопотенційно здатні фарби, які здатні тверднути під дією ультрафіолетового випромінювання шляхом УЕФ-полімеризації. І це дозволило значно пришвидшити технологічні процеси, так як полімеризація відбувається за долі секунди, а фарбовий шар утворений володіє хорошою зносостійкістю і забезпечує високу яскравість відбитків. Але поряд з цим технологія і суспільство стикнулося з такою проблемою, як незначне порушення технологічного процесу може призвести до неповної полімеризації фарбових шарів, відповідно утворюється залишковий запах, а також може відбуватися міграція компонентів фарб в процесі експлуатації. Тобто, якщо говорити про застосування і експлуатацію тих відбитків, то передача або міграція компонентів фарб може відбуватися через контакт на зворотню сторону. Це може відбуватися в стопі або в рулоні при виготовленні упаковки. Може відбуватися дифузія компонентів фарби через задрукований матеріал. І також випаровування компонентів фарб, які так само можуть в процесі експлуатації переходити на поверхню упакованого продукту. Відповідно, було проведено дослідження. Дослідження полягало в дослідженні, як впливає ступінь полімеризації фарбових шарів на залишковий запах. І також, спираючись на дослідження впливу молекулярної маси компонентів фарб, а це особливо стосується фотоініціаторів, Відповідно, побудована логічна схема впливу цих компонентів, тобто ступеня полімеризації і молекулярної маси фотоініціатора, і встановлено, як це видно в таблиці 1, як ступінь полімеризації впливає на сам запах. Запах оцінюється шляхом опитування, відповідно до стандарту за шкалою. 0 балів – це є відсутній запах, а 4 бали – це є великий запах. Це опитування несе в певній мірі таку нечітку форму, і тому для подальшого дослідження нам було використано засоби, чи, як кажуть, інструменти нечіткої логіки. Відповідно, були сформовані для двох змінних молекулярна маса фотоініціатора і ступінь фотополімеризації фарбових шарів була сформована універсальна множина, і, відповідно, встановлені відповідні терміни. Було за результатами опитування і експертних і експериментальних досліджень було встановлено так звану базу знань. І ця база знань стосувалася, як фактори впливають, коли є низька міграція, коли є середня міграція і коли є висока міграція. Побудовані були відповідно функції належності для двох факторів. І відповідно за функціями належності і базою знань було побудовано модель впливу даних факторів на міграцію компонентів фарб на упаковку. Ну і за результатами моделювання були досліджені різні варіанти міграції компонентів фарб в залежності як від молекулярної маси фотоініціатора, так і в залежності від ступеню полімеризації фарбового шару. І таке моделювання нам дозволило провести так зване прогнозування можливості впливу даних двох факторів на міграцію і шкідливість, яку вони можуть принести в процесі експлуатації упаковки. І так коротко моя доповідь.
Thank you, Vyacheslav. Questions, please? No questions? Okay, thank you, Vyacheslav. Now we end the current part of section first, Intelligent Information Technologies. Thank you to all the speakers for very interesting presentations. I wish everyone new interesting scientific results. We will continue our section first tomorrow at 11:30 a.m. And today from 4 p.m. we will have continue of the section second, Systems of Information Security. Now we have a short coffee break. We invite everyone to continue working at the workshop after the coffee break. Good health to all, and 36 and 6.
Thank you.